For our project, we have created a classification of toxic comments using various models. We have done this because social media recently has amplified many voices, and hiding toxic comments could potentially create a space where discussions are more free from abuse and harassment. We are comparing between a naive Bayes model and an LSTM model to predict whether a comment is either toxic or non-toxic, and then we compare between the two to see which one would be better to implement in the given context. We have used the dataset from Kaggle's Toxic Comment Classification Challenge. This data was compiled from many different Wikipedia comments, which were labeled using 6 categories. These categories are toxic, severe toxic, obscene, threat, insult, and identity hate. Each of these comments are pre-processed and vectorized based on the counts of tokens within them. We then input these vectors and a set of labels corresponding to the comments into either model. And here's a quick example of what one of these comments would look like. We have a unique ID, a comment text, and then these 6 different categories with a 1 representing if it belongs in that category or a 0 if it does not belong in that category. Our output is a list of label predictions created by either model. And this is just a list of 0s and 1s, where 0 represents if it is non-toxic or 1 represents if it is toxic, and each spot in the array is for an individual comment. For our approach, we group the data and split it 80%, 20% for training and testing. We pre-process and then vectorize this input data, which we then feed into a naive Bayes or LSTM model for training. And then we make predictions using the trained model when we run it on the testing data. Our test accuracy, precision, recall, and F1 scores are then outputted based on the predictions that were made by the model. Here's our naive Bayes model. It uses the Bayes theorem, which you can see in the bottom right. This uses a proportion of toxic or non-toxic data to calculate the probability of toxic or non-toxic comments appearing. And then we transform these comments into vectors with counts of tokens, and we train the model on the training data, and then run a prediction on the testing data later using the trained model. For the LSTM design, the data is pre-processed using Keris's tokenizer, where the most common 20,000 words were kept. Afterwards, the text is then transformed into sequences of integers. These sequences are padded, with each sequence having a maximum length of 150. The LSTM model has a total of 8 layers, with 2 being activation layers. The first activation layer uses the ReLU function, and the second activation layer uses the sigmoid function. For our evaluation metrics, we look at the accuracy, which doesn't always give the best idea of how well a model performs. So in addition to that, we also look at precision, recall, and F1 score. The precision is a percentage of selected classes that are correct. The recall is a percentage of correct items which were selected, and the F1 score combines the precision and recall to give a better summary of how the model performed, and you can see the F1 score calculation on the right side there. Here are the confusion matrices for the naive Bayes and the LSTM model. As you can see, the LSTM model correctly predicted a substantially larger amount of true negatives than the naive Bayes model did. And the LSTM also predicted fewer false negatives. However, it did have a few more false positives than the naive Bayes model. We can see that overall the LSTM improved in multiple areas when compared to naive Bayes. It has a much higher accuracy and average F1 score or recall. This could also be due to the naive Bayes independence assumption, where the probability of one event is independent of another. And LSTMs are also a much more complex system, so we definitely expected them to have better results in this context. And as we can see, that did end up being true. Ultimately, we concluded that the LSTM is overall better for this context. The LSTM has a higher accuracy, average F1 score, and average recall. And in the future, we could expand the scope of our project by trying different models like CNN, or we can try using these models to do multi-label classification. Here's a quick list of our references for our images and models used, and thank you everyone for watching.